All right, the evidence is getting stronger and stronger that humans are responsible for changing the global climate. Joining us now is one of the authors of the latest climate change report, Dr. Lynne Talley, who's a professor of oceanography at UCSD. Welcome to the show, Lynne.
Thank you. I'm glad to be here.
Well, you know, we have heard for many, many years that humans are responsible for changing the global climate, and it's very controversial. Some people believe it, some people don't. But tell us about the latest report and how it then affects San Diego.
Right. Well, there are many aspects to it. The most important thing is that this is nothing new. This has been reported as completely incontrovertible evidence, at least several times since 10, 15 years ago. This latest report presents evidence that makes it even clearer that the climate is changing. It makes clear what aspects of climate are changing, not just the global mean temperature. We've already made a very strong statement in 2007 that the global mean temperature is unequivocally rising. That still remains true. And moreover, now we can say with much greater confidence where the heat is going in the climate system, and with much greater confidence trace it to basically burning of fossil fuels, carbon dioxide rise in the atmosphere.
And a lot of that carbon dioxide gets trapped in the ocean as well, right? Which is changing marine life.
Yes.
Which that in itself affects us because the waters are getting warmer. It's trapping what percentage of the CO2 goes out into the atmosphere, and what part goes into the ocean percentage-wise?
Right, so when we burn fossil fuels, we release CO2 into the atmosphere, and of that 30%, so more than a quarter of it, ends up in the ocean. So the oceans are huge. Most of the planet, 75% of the planet is covered with ocean. So there's a lot of surface area. There's a lot of exchange of gases between the ocean and the atmosphere, and so that's where the 25–30% of the CO2 goes into the ocean. The rest of it is either in the atmosphere, sort of half and half in the atmosphere and half in the biosphere. It goes into making plants greener. It goes into all kinds of things on land. The part that goes into the ocean is useful because it draws the CO2 down from the atmosphere, but that still leaves us with a large amount of excess CO2 in the atmosphere for all the amount that we burn. You mentioned effects on the ocean itself of the CO2 that goes in. When you dissolve CO2 in water, so take a drop of water, you can do this in a cup. Take a cup of water and a straw and a piece of litmus paper. If you blow into the cup, you're blowing CO2 out of your mouth. That's natural CO2 we all breathe out. And if you measure that cup's pH, you'll find out that it got slightly more acid because you breathed into it. So the CO2 goes into the water and it turns into several different things. It doesn't stay as a gas mostly. And one of the things it does is makes the water more acid. So all rainwater, all seawater is slightly acidic because of that. That's why rainwater can corrode sidewalks and buildings and things like that.
And is it more acidic now than it was 3 decades ago?
Absolutely. So it's clear we make measurements of the pH of the acidity of the ocean or of other things that matter for pH. And as we have been able to see over several decades that the pH has changed and the ocean has become more acidic. And this is a problem even right here along California with very important fisheries. What happens when the water becomes slightly more acidic is that it becomes more corrosive to things like sea shells, so shellfish, developing bones, developing small things like sea urchins, things at the base of the food chain out there, all suffer as the water becomes more acidic. The other effect on those organisms is the temperature. As the temperature rises, then also they have more trouble. So there's kind of a threshold you pass with temperature and acidification where organisms struggle a lot more.
And their life eats those organisms for sustainability.
Right, and we also have commercial fisheries out here that care, and so actually part of the California ocean observing system is beginning to include measurements of the pH, basically the acidity of the ocean out there, so that they can report in real time if there are acidification events. Sometimes water comes up on a shelf that's more acid, or maybe has lower oxygen, which can also be tracked to global change. And so these events coming up are extremely important to the fishermen along the coast.
Because it will kill off the fish?
Extreme events would kill off the fish, but mostly it just causes problems, issues, makes them develop. It's not the fish so much, the shellfish. The shellfish would suffer from that.
And is it true that our waters are getting warmer as well?
Our waters in general are getting warmer. The warming of, definitely. So the heat, we put CO2 in the atmosphere. It acts somewhat as a blanket. It makes the whole thing a bit warmer. So the atmosphere has gotten warmer. The ocean has also gotten warmer. And actually, if you look at the heat, but not the temperature, heat, 93% of the extra heat is in the ocean, not in the atmosphere. So one of the sort of interesting facts is if all of that heat were in the atmosphere, we'd be 100 degrees warmer now. But instead we're only 1 degree warmer than we were 100 years ago.
Because the ocean is like a sponge and it's soaking up that heat.
Water holds heat much better than air, as you can imagine just from kitchen experiments.
And thankfully we have the ocean, right? We can't let
We have it to absorb some of the CO2, but not all of it.
Right.
Definitely not all of it. And we have it to absorb a lot of the heat. As it absorbs heat, when you warm water, it expands. And that's part of the sea level rise.
And that's part of the report as well that you're seeing is the sea level rising, correct?
Right.
So talk about that.
So there's a group of experts. I'm not one of them. I measure something else. But the experts measuring sea level change can show that there's been a change of about this much in the last 100 years. That's in one direction, up.
Yeah.
Not down, not variable, but up. And they can tell us what that's due to. And about half of it is due to the warming of the ocean, and the other part is due to melt of ice sheets and glaciers, extra water that goes into the ocean.
And they're melting because the Earth is getting
warmer. Right. So the Earth is warmer, ice is melting, snowpack in California is melting earlier, there's less of it. There's more rain than snow now than there was a decade or so ago. And these are all observations that we make. We can see the changes, and there's really no way to discard them just because you want to believe one thing or another. These are real changes, and that we really do can attribute with great confidence to the increase in CO2 in the atmosphere.
Is it true they've been testing all of this for like 3 decades at a time and they've seen these significant changes? I mean, so there's proof in the pudding.
Yeah, well, we've been measuring all kinds of things. So,
and I'm talking more like global changes as far as the Earth getting warmer.
Right, so we've been measuring temperature since the 1800s, and then we can also see what the temperature of the planet probably was 300, 500,000 years ago from other types of records, like buried in tree rings and so forth. So we have records. We have instrumental records with actual thermometers for 100 years or so. And then in the last 50 years or so, since the 1950s, we've had really excellent global coverage. And we measure all the way up to the top of the atmosphere. We have satellites now since the 1970s, and that gives us really good records of the full planet. So now we have 40 years of satellite records. And all of those show that the Earth is warming.
So all of the evidence is conclusive that the Earth is warming.
The Earth is
all
warming.
Those skeptics out there, it's like
what can they do with that fact?
It's like believing the Earth is flat. Perhaps if they argue this point, right?
Right.
I know. It's so, but it's still so controversial. It blows my mind.
What makes it hard for people to grasp is that the warming is 1 degree Celsius. And you can say, well, I went through 1 degree Celsius coming into this building. Because you're used to that being a very small fluctuation. It went from this morning to lunchtime. What matters is that it's 1 degree over the whole world, and it's a trend. It's gone that way. And that has a big effect on rainfall patterns, has a big effect on how much moisture the atmosphere can hold. That affects the rainfall, where it evaporates and where it falls someplace else. It affects snow. It affects you name it. So they can't argue with this measurement They certainly can't argue with the measurements in the ocean that show it warming as well over the last 50 years.
And the CO2 levels and the acidic levels.
And the acidification of the ocean, and then we know from just measuring CO2 in the atmosphere how much it's gone up. And we can attribute with great confidence the temperature change and the sea level change and the rainfall changes in out at the ocean to this warming.
Let me ask you, is there anything we can do now to reverse the changes?
Reversal's a little difficult.